Hello. So we're going to do our learning check on stoichiometry today. You know the drill by now. You're going to take notes on it, upload your notes, including one sentence on what's doing well and sentence on or one sentence on what you're struggling with. Okay. For this one, you're going to have to do all three steps here. Predict the products, write the balanced chemical reaction, and determine how many molecules of iron 2 sulfide you get from the reaction of 25.0 grams of silicon dioxide reacting with iron 2 sulfide. So that just means stoich. You're stoiching from grams of silicon dioxide to molecules of iron 2 sulfide. So there's your hint. Go ahead and pause. And welcome back. All right. So first, predict products. Well, first I need to know what I'm dealing with. Silicon dioxide, SiO2, covalently bonded. So I'm using those prefixes. Di means two. Silicon does not need a mono, but he is one. Reacts with iron 2 sulfide. Remember that iron, when we see that Roman numeral, that means a positive charge. Transition metals need Roman numerals. And sulfur is a -2, so that's FeS. So those are our two reactants. SiO2 reacts with FeS to yield what? I don't know. Well, first I got to figure out what type of reaction it is before I predict products. I have two couples. Two couples mean that it's going to be a double replacement. And the method for double replacement is cation swap. Okay. The inner are now going to be together and the outer are now going to be together. So iron is now going to be with oxygen. Iron plus 2, unless they tell you otherwise, assume same oxidation state. Equal and opposite, so you can just smush them together to FeO. And silicon is now going to be with sulfur. Silicon was a cation here, sulfur is an anion. So I'm going to write it the same, cation, anion. Sulfur is a -2. Silicon in its cation form is +4. All right, so here, let me crisscross. 4, 2, simplify. They both can be divided by 2. That gives me SiS2 as my chemical. All right, let's balance this guy. One silicon on the left, one silicon on the right. 2 oxygens on the left. So on the right, remember, no changing subscripts at this point. You already have the words spelled correctly with the formula. So I do a 2 in front. That means I now have 2 irons and 2 oxygens. So 2 oxygens is good. That's what I had before. Now I need to add 2 irons over here. 2 irons also give me 2 sulfurs. Oh, but I'm in luck. There was 2 sulfurs there. Okay. If the chart method makes more sense than logicking out, yes, use the chart each time. The chart actually reduces the chance of error. Either way is fine. Just make sure at the end, 1 silicon on the left, 1 silicon on the right, 2 oxygens on the left, 2 oxygens on the right, 2 irons on the left, 2 irons on the right, 2 sulfurs on the left, 2 sulfurs on the right, which means conservation of mass is met. We did not magically create any elements on either side. We have the same number everywhere. All right, so now my equation is balanced. Determine how many molecules of iron 2 sulfide there are. Okay, molecules. So that is our goal. What is our start? 25.0 grams of silicon dioxide. Now you can write it up there, or you can write it exactly how we did it in Unit 1. Okay. 25.0 grams of silicon dioxide equals how many molecules? Oh, not how many molecules of silver sulfide, sorry. How many molecules of iron 2 sulfide? Because that's what they asked for in the question. Okay, and what do I need to do? I need to do stoich. If I do stoich, it's going to tell me the exact number of molecules matches 25 grams of silicon dioxide. 25.0 silicon dioxides over 1. At this point, yes, you should have the number, which is called the magnitude, the units, and the species, the molecule or the compound right there, so that you don't accidentally make any mistakes. All right, so I'm going from grams to molecules. Molecules are not moles, so I have to go from grams to moles to molecules. Between grams and moles, that's molar mass. Between moles and molecules, that's Avogadro's number. Well, Avogadro's number is fixed. 1 mole is equal to 6.02 times 10 to the 23rd molecules. And molar mass is unique for each element. So I need to find the molar mass of silicon dioxide. Silicon, according to the periodic table, is a mass of 28.09 grams. And oxygen, there are 2 of them at 16.00. Okay, when I add that together, I get a molar mass of 60.09 grams is equal to 1 mole. So that is my first conversion. There is my second conversion. I'll have to do more though, because remember, I also have to convert from moles of silicon dioxide to moles of iron 2 sulfide. All right, so I'm just going to start here. Grams of silicon dioxide, grams to moles. Molar mass is my first step. Mole ratio is my second step. I get that from the equation. And then Avogadro's is my third step. Okay, there are 60.09 grams in 1 mole of silicon dioxide. Mole ratio. It is still following that same format. Unknown units over known units. Okay, so my unknown, what is my unknown? My unknown is FeS. So moles of FeS goes on top. My known units, my known is silicon dioxide. So moles of silicon dioxide goes on the bottom. Same formatting. But to get these mole ratios, I have to look at the balanced reaction. So if you didn't balance your reaction, you're missing a whole conversion. There are 2 moles of FeS for every 1 mole of silicon dioxide. So now what happens if I cancel here? Grams, grams, moles of SiO2, moles of SiO2. So now I have my answer in moles of iron sulfide, but I want to know molecules. Same thing works. I'm now going from moles to molecules. I use Avogadro's. Moles is my known, so moles goes on the bottom. Molecules is my unknown, so it goes on the top. In 1 mole, there's 6.02 times 10 to the 23rd molecules. All right, so now I have that whole long equation. Let me clear off some of this bottom here so that we can see when I smush it all together. Okay, the numerator is now going to be 25.0 times 1 times 2 times 6.02 times 10 to the 23rd molecules of FeS. And the bottom smushed together is 1 times 60.09 times 1 times 1. Okay, so 25 times 1 times 2 times 6.02 e to the 23rd. That gives me a top of 3.01 e to the 25th. I'm going to divide that by 60.09. There we go. Okay, and I get an answer of 5.00915 e to the 23rd. Sig figs, I started with 3, I need to end with 3. 5.01 times 10 to the 23rd molecules of FeS. Put your answer in magnitude units and species. All right, so that is problem number 1. I'm going to stop the recording now and start in the next one.